by the right button on the mouse. Click on deformed mesh here, magnitude factor. In my case is 20, it should be fine. Okay, this is the deflection curve. We can check the vertical displacement at point A. Did you discuss? Okay, so the vertical displacement. We can use again values. Okay, so now we want to check the value of the vertical displacement at B, the free standing point here. So here we go again on values on the left, values, on, turn it on, and double click on values, double click. Instead of entity reaction, as entity we select displacement, so the second one from the top, displacement, and component, of course, if we put the X, it would be 0 because the analysis in small displacements, so no horizontal component. Vertical component is the one that we are looking for. So dy, please select dy component. Okay. Of course, here if you click, you see something that is not what we expect. So go again on values and click on values display. Values display. Here you can select maxima and minima with signs. It means positive and negative. So maxima and minima. Minima will be 0 in our, maxima will be 0 in our case. Minima will be the maximum negative displacement. If you put 10% here, it will show you maxima, minima, and values no far more than the 10% from maxima and minima. If you put 0, you simply see maxima and minima values, okay? So maxima and minima. If you click on deform on the right here, deform, values will appear close to the deformed configuration. If you leave it unchecked, this box, you see the values close to the undeformed configuration. I prefer clicking here for deform and apply. Okay, as you can see here, you have the minimum value, that is minimum in absolute value 0, so no displacement, no vertical displacement at A, where you have the fixed support, and the maximum vertical deflection at B. That is equal to, in our model, minus 3.9872 e to the minus 3 meters. So these are 3.98 and so on millimeters. That is the same as the PDF. Rinto, do you have the PDF here or not? Okay. Wait a moment, please. Okay, thank you. If you look at here, VB due to M is minus 3.9872 millimeters. Exactly the same solution that we found right here. Okay, so with this is an approximate value, of course. Here you have 4 digits after the dot in the PDF. Here we have one more, but it's the same result. Okay, if we want to change the model and also include the shearing deformability to get this final value, here the contribution due to shearing deformability is, as I told you, 3 orders of magnitude smaller than the previous one, but if you take it into account and you make the sum of these two values, you get this vertical displacement. So in this case, we need to modify the model. So, of course, internal force diagrams will not change because the solution is obtained under the assumption of small displacements. This is a linear analysis where the equilibrium is written in the undeformed configuration, so without including the displacements into the computation of the lever arms, for example. So the bending moment will be again F times the distance L in the undeformed configuration. So we will get the same internal force diagrams, but different values for the displacement. So I suggest you to take this exercise this file as it is. So save it if you want. We can save with a new name, a different name, another file to modify the mesh and some attributes. Okay, so I do like that. File, save as. All results will be closed. Yes. Okay. I call it. I add here a thick. So like. Okay, I write here thick. The previous one was thin, for example. Now we can call it thick. Thick, okay? Save. Now I'm working on another model, okay? Thick. What we need to modify in the attributes is the mesh, because instead of selecting thin beam, we should select thick beam, and also the geometrical properties, because before we selected 2D thin beam and we have inserted A and I, cross-sectional area and moment of inertia. In this case, we need to add also the shear shape modified area. So we can deselect, so here, deassign the attribute. So click on it, right button, deassign from all, for the geometrical property, and also for the mesh. So deassign the mesh from all. Deassign from all. It's not deassigning it, I don't know why, maybe. I hope it will react. We will do it later. So we can or create a new attribute or modify the existing one. To be faster, I will modify, since we have a few minutes left, I will modify the previous attributes and call them with a new name. So double click on line mesh 1. So change from thin beam to thick beam. So please select here just thick beam, no other stuff. Thin beam, thick beam, 2D and linear. In this case, the interpolation order is linear. I call it thick. Apply, and a new attribute appeared here, thick. The previous one was thin, this is thick. Then the same for geometry. Geometry, I modify. From 2D thin beam, I select 2D thick beam. 2D thick beam. As you can see here below, a new box appeared. This is for the effective shear area in Y direction, what is called ASY, here and also in the PDF. I don't remember the value, I need to check it here from the PDF, from data here. ASY equals to 1 times 10 to the minus 3. So I will write here, all the other properties are the same. I write 1E minus 3, E negative 3. I call it with a different name. I can add, for example, thick. Apply and close. I assign these new properties and run again. So I can deassign. I hope it will allow me deassign this attribute from all. No, I don't know why, but I will solve the problem. Maybe the model is locked. The mesh is locked. Ah, okay, because it was. Thank you, Rit. So deassign the first one and assign the second one. So please select the beam, assign the second line mesh, and also assign the second the new geometrical properties. Once assigned, you can click the solve button. Okay, it's fine. Okay, here, as you can see, the vertical deflection at B is equal to minus 3.9922 millimeters. The same result of the analytic solution, okay? That is this one, okay? Minus 3.9922. The next time we will modify the model to calculate the internal stresses due to the bending moment. But for this for today is enough, and we can compare the two solutions, and if you plot again the internal force diagrams, you get the same results as before. For example, here, no, maybe attributes here disappeared from, okay, no, it's here. Okay, attributes, no, layers. If you activate again diagrams on, I need to, okay, because entity, force for 2D thick beam, Fy, okay, minus 500, constant, and if you change for mz, the same as before, linear function from 400 to 0, okay? Okay, that's all. I will be back in my virtual classroom and stay a few minutes for answering to any possible questions, and we will see again the next week with a new classroom. Okay, bye bye. Thank you. Thank you, Rita. You can